Okay, so we talked about several theorems on Friday. There were 5 different characteristics of parallelograms that you guys needed to know. Essentially what we're talking about today is the converse of all of those. So again, what does converse mean? If I say like, if it is rainy, then it is wet, converse would be, if it's wet, then it's rainy. So converse just means flip it, right? So basically when we talk about the converse of a theorem, on Friday we said, if it's a parallelogram, then it has opposite sides are parallel and congruent. Now we're saying if opposite sides are parallel and congruent, then what can I say about that shape? Then it's a parallelogram. Exactly. So you're just reversing the order of what we talked about on Friday. So all these conditions are the same 5 theorems that you talked about as characteristics of parallelograms on Friday. So 6.3.1, don't forget what I said either, which is that like this right here, you don't really need to know the numbers. You just need to be able to describe the stuff. So in a 2-column proof, I don't expect anybody to memorize 6.3.1, but I would expect you to say like opposite sides are parallel and congruent. Does that make sense? Okay. So opposite sides are parallel and congruent. What do I know about opposite pairs of sides? They have to be what? Both of them have to be congruent. So BC is congruent to AD, and AB is congruent to DC. Good. All right, what about opposite angles? Also congruent. Opposite angles are also congruent. What about consecutive angles? Add up to 180. This right here, this example, this just means they add up to 180. Because if this one is x, how would you find this one? 180 minus x. So that's all that picture means, that those 2 angles have to add up to 180. All right, and then what are these things? Diagonals. What's a diagonal? One corner to the other corner, or like one vertex to a non-consecutive vertex, right? Because if it were to a consecutive vertex, then that means this would go straight down here, and that's not a diagonal. So diagonal basically goes across the shape from one vertex to a non-consecutive vertex. And in a parallelogram, what do diagonals do? They bisect each other. What does bisect mean? They cut in half. Okay, so what we're going to talk about today is if I give you something, you have to prove to me whether or not it's a parallelogram. So this right here, show that ABCD is a parallelogram for x equals 7 and y equals 4. Looking at ABCD, what information do they give you? Do they give you diagonals? Do they give you sides? Do they give you angles? Sides. You know that, what do you know about the sides of parallelograms? Opposites have to equal each other. Okay, could you prove that these are parallel with this information? Yes. Yes, you could prove that they're parallel? Parallel, no. Could you prove that they're congruent? Yes. How would you do that? Well, take a look at the information that it gives you. Yeah, just plug it in. And if you want to set them equal to each other and then plug it in, that works too, okay? So, for instance, x plus 14, what would that really be? 7 plus 14, which is 21. All right, what's x times 3? 21. All right, so those are congruent. What about the opposite ones?
16.
This would be 16 because 5 times 4 is 20 minus 4 is, okay, what about over here? 4 times 2 is, 8 plus 8 is, okay. Do you need to do anything else? No. Why? The opposite sides are congruent, therefore this has to be a parallelogram. That's it, okay? So that's it. So the opposite sides are congruent. All right, so opposite sides are congruent. So ABCD is a parallelogram. All right. What theorem would that be if you did want to look at the numbers?
6.31.
6.3.2. Why is it 6.3.2?
Because one is they're parallel.
One, you only need one set of sides. It has to be parallel and congruent. Here, we don't need anything about parallel. We just need to know that they're congruent. Okay, so you could...
If they're congruent, doesn't that mean that they're parallel?
No, not necessarily. Because this line, like this, could be congruent to this, and those aren't parallel. Congruent just means same distance. Okay, what about this? All right, they're showing you the angles. What do we know about the angles in a parallelogram? So we need F to be equal to H. All right, and what else? And we need G and H to add up to 180. Okay, or F and G, either one of those. Good. So how am I going to start? Which one am I going to do first? F and H. All right, so let's start with F and H. What am I plugging in? 99 plus 19. Okay, someone with a calculator confirm that, but I believe that is 118. 118? Okay, 118. 121 minus 3, which equals, perfect, 118. All right, and then G, I'm just going to plug in. Okay, so 14 times, good, somebody do 14 times 4.5. 63 minus 1. 62. Okay, good. Now, what do I need to confirm? That if I add those two, what does it give me? 180. So is this a parallelogram? Yes. What theorems did you use to prove that? 6.3. Okay, I'm going to say it has to be 6.3.4. Why is 6.33? Why is it not 633? It's not all four. Okay, we only had 3 of the angles, which means we had to use the consecutive angles equal 180. It would not be enough to prove that F and H are equal, unless we also knew that E were what? 62. Okay, if we had E as 62, then we could use 633. Here we have to use 634. And again, I don't expect you to memorize those, so you could also just write consecutive angles equal 180. Oh, like if you put 5.3.4? I mean, I think your safer bet is to just write these 3 words. Like, because there is a 5.3.4, you know? So, yeah. I would just do, like if you tried to write that? Why? Always if you over-explain yourself and get it remotely right, I'd rather have that. Does that make sense? So I'd rather you say, like, I'd rather you have to babble on a little bit and, like, get to the point than try to memorize theorem numbers and get them wrong. Okay? All right. Okay. Does A have to be a parallelogram? Do you have enough information in A that it has to be a parallelogram? But I have parallel sides.
But they're not congruent.
Okay, but I have congruent sides.
They're not parallel.
Oh, okay. Where would these arrows have to be for this to work? On the same one. I would need this for that to work. So here, it might be, we just can't assume. So we'd say not enough info.
Wait, you saying they have to be on all?
No, you'd have to have, for parallel and congruent, look back at theorem 631. You'd have to have them on the same line. I could know nothing about these two, BA and CD, but as long as I have these 2 pieces of information about this one, I can use this theorem. All right? Congruent, you need all 4. Like if you don't know anything about parallel, you need all 4. Okay, what about B? Yes, why?
Because all the middle parts
Which are called? Diagonals bisect each other. So yes, this is one. And again, what's bisect? Good, cut in half. Okay, go do these 6. The last 4 are just yes or no's. Okay, so in number 5, why is 5 a no?
because they don't have the same line on the top. Like not parallel.
Okay, you know that the top and bottom are parallel, but you would also need to know that they are congruent. Okay, good, which is why number 3 is a yes, because you have the same ones are parallel and congruent. All right, number 4, what's the justification there?
They're all
Yes, but why? Diagonal bisects each other. Good. And then what about 6? Yes or no?
Yes.
Why?
Opposite sides.
Opposite angles are congruent. Good. Opposite angles are congruent. Okay. So on a coordinate plane, how could you show that quadrilateral ABCD is a parallelogram using the definition or theorem? So the definition of parallelogram is what? What's a parallelogram?
The opposite sides are
Opposite sides are congruent. All opposite sides are congruent. So what's one way that you could prove that this is a parallelogram? What do you mean?
like to go up.
Which would be finding the rise over run, which is the slope. So what would that tell you? Slope. How could you use slope to prove that it's a parallelogram?
How many squares is it?
If what is the same? Why? If the slope is the same, that means that they're not that they're congruent. The lines are parallel. Good. Could you also use the distance formula?
Yes. No, it's too
Yes.
long.
Okay.
Yes.
It's too long.
Okay, so you could also use the distance formula. I think it's easier to use the slope. I think it's easier to use the slope if they're just asking you based on definition of parallelogram. Because definition of parallelogram could just be that opposite sides are parallel. So then how do we find the slope of, say, like, let's start with BC. I go from B. How far do I rise? All right, I rise -3. Why is it negative? You're going down. And then how far over do you go? 4. Okay, this one has to be the same as which one? AD. So how far down do I go on AD? -3 and 4. Okay, so are those two parallel? Yes. All right, is that enough? No. What else do I need to prove? Okay, BA and CD. Is that enough? Like, is this one of the theorems that we had? No? So I don't really, like, I could prove that, and it's true, but I also need to show what? That they're congruent. I also need to show that BC is congruent to AD. So that means I do have to use the what? All right, what's the distance formula again?
Something one
Minus
times.
y1 parentheses 2 right there. Yes. Plus x y 2. Yeah, I'm tired of.
Okay. All right, so you're basically just doing x minus x, y minus y. So I want this half of the room to do BC and this half of the room to do AD. So you guys do AD, you guys do BC. Here are your coordinates right here.
Before Christ and after Christ.
Look at that. You guys are doing AD, you guys are doing BC. It is Anno Domini. Can you find AD, the distance of AD? I am. Never been sure of anything in my life.
Sure.
Sure. It is right now.
Sure. The bird is.
Miguel.
Okay, they both should have been what? They should have both been 5. All right, so that means that square root of 25, which is 5. What'd you get? Okay, all right, I'll look at it in a minute. All right, which proves that BC is parallel to AD and BC is congruent to AD. Therefore, is this a parallelogram? Yes. Good. Okay. All right, using theorem 6.3.1, so that's the one we just used, I want you to prove the same thing. We're not going to actually do it because we just did it, but what would you need to prove here? If you're using theorem 6.3.1, what would you need to prove? You would need to prove GH and FJ are congruent and parallel. Or you could prove that GF and HJ are congruent or parallel. One of those. So you've got to find the slopes and you've got to use the distance formula. Okay, so, all right. We don't have time to do these practice problems, so I just want you to do the exit ticket. Yeah, you should be able to finish the exit ticket. When you finish it, show it to me, and then you are done for the day.